Hello students, and welcome to this lesson on perfect squares and simplifying non-perfect squares. Alright, so we're getting into our unit on special right triangles, and in special right triangles we're going to be working with sine, cosine, tangent, and those values are often defined in terms of a ratio, particularly a ratio between rational numbers and irrational numbers. So before we get into our unit on special right triangles, first we want to spend some time reviewing how to work with square roots, how to work with rational and irrational numbers, the radical symbol, and all of our rules that will go along there. So our objective today is that we will define perfect squares and simplify non-perfect squares using notes and practice problems. Alright, so what is a perfect square? Well, you guys are already very familiar with these. They're a number made by squaring another whole number. So we can write our definition in here. And that is a number made by squaring a whole number. And our example here, just quickly, is that we'll say that 3 squared is equal to 9. So therefore, the square root of 9 is equal to 3. So you guys will be able to pick up a chart of some of the perfect squares up to 400, and you'll see it'll be really useful to have that chart because you'll be able to recognize those, and that'll be really important for when we're simplifying radicals. So go ahead and glue in that chart below here and fill in all of the numbers. So it starts at 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc., etc. So go ahead and fill in that whole chart. Alright, then we want to come up with a procedure for simplifying non-perfect squares. So our first step is going to be that we're going to break apart the number inside of the radical. So if we're starting an example down here, we can say the square root of 200, and our step 1 is to break apart the number inside of the radical so that it becomes maybe a perfect square in some other number. So if I'm thinking about how to break this down or factor this number, I could say maybe the square root of 2 times the square root of 100, right? Because I know that 100 is going to be 10 squared, so that helps me out here. Then my second step is going to be to take the square root of the perfect square that has appeared. So obviously we found that it was the square root of 100, and that's going to become 10. So now we found the perfect square of the square root of the perfect square that was in there. Alright, and then our third step is that we're going to rewrite the whole number outside the radical. So we have our whole number here, and then we have what's left underneath the radical here. So we have 10 square root 2. So 200 is the same thing as 10 square roots of 2. Sorry, the square root of 200 is the same thing as 10 square roots of 2. Alright, so for example 2, we're going to look at the square root of 96. And so 96, again, we're going to try and factor it here. And I see, and we want to factor it into something that has a perfect square as well. So maybe here we could say 16, right? So the square root of 16 and the square root of 6, maybe. And then 16 right here will be 4. And then square root of 6 is just the square root of 6. So we will rewrite our expression here as 4 square roots of 6. So the really hard part here, in my opinion, is going to be the factoring. So just make sure that you are thinking about different ways that you could factor these. Alright, so on your own or with a partner, go ahead and take a crack at example 3 and example 4. If you need any help, just ask around. So the square root of 216 is going to be example 3, and the square root of 18 is going to be example 4. Alright, so the next thing that we're going to talk about is multiplying radicals. So again, we're working with them a lot in the future, so we need to make sure that we have these skills very good. So let's just go through a problem and see what the steps are. So our first step is going to be multiplying the outside coefficients, if there are any. So in example 5, we actually have some outside coefficients. So we have the outside coefficients here, 2 and 3. So we'll multiply those together first. So this becomes 6 times the square root of 7 times the square root of 7. So now we're here. Then we want to multiply what's ever underneath the radicals. So again, we're going to take our two new things. So we've got 6 times the square root of 7 times the square root of 7. So this becomes 6 times the square root of 7 times 7. And this is going to become 6 times the square root of 49. And obviously this will turn into something. So from here, we want to simplify. So right now I have 6 times the square root of 49, but I also know that the square root of 49 is just going to be 7, so this is 6 times 7, and so this is going to be 42. So I'm going to run through example 6 here. So again, we're going to multiply the outside coefficients, so this becomes 3 times 7, so this is 21 times the square root of 6 times the square root of 12. Then we're going to multiply what's underneath the radicals, so this becomes 21 times the square root. 6 times 12 is going to be 72. Alright, and then we're going to simplify what's underneath here. So the square root of 72 is going to simplify into 21 times 6 square roots of 2. And so then we just need to simplify from here, and you're going to get that 126 times the square root of 2 will be our answer here. And you might be wondering where the 6 came from in 6 square roots of 2. Well, if you take 72 and you factor it, you can factor it into 36 and 2. And so then you take the square root of 36, and that becomes 6. So go ahead and try this with problem number 7, and then continue on to the next section. Alright, and finally we can see something about dividing and rationalizing radicals. Alright, so in example 8, we're going to see that we have the square root of 6 over the square root of 2. And interestingly enough, if you have a situation like this, all you have to do is follow the exact same steps as multiplication. Except now you're going to be replacing the word multiply with divide in every place. So step 1 is divide outside coefficients. In this case, there are none. Step 2 is divide numbers inside the radicals. So we have two numbers inside radicals, and they are being divided over one another. So this becomes the square root of 6 divided by 2, or this becomes the square root of 3. We can also do example 9 here. And what this will be is we have 2 square roots of 27, and this is being divided by a square root of 3. And now we want to follow our same steps. You want to divide outside coefficients, if any. Step 2 is divide numbers inside the radicals. So we're going to divide the numbers that are inside the radicals. So 27 divided by 3 will become 2, and then square root, 27 divided by 3 is 9, and then we simplify. So this is 2 times the square root of 9, which is 2 times 3, and that's going to be 6. Alright, and the last thing that we need to talk about is rationalizing. So when we're rationalizing, we're pretty much taking something that looks like this. We'll call this example 10. So we're taking example 10, and we're going to have it as 8 divided by the square root of 2. Now we don't like this form. We don't like it when we have a radical in the numerator. I'm sorry, we don't like to have a radical in the denominator. We prefer the radical to be in the numerator. So we want to get this square root of 2 up here somehow. So how can we do this? Well, there's a simple little process that we can go through. And that process is that we can multiply the numerator and the denominator by the radical in the denominator. So why can we do that? Well, it's because if I ask you what square root of 2 divided by square root of 2 is, that's going to be 1. So it actually doesn't change the expression at all. So we take 8 divided by the square root of 2, and I want to multiply it by the square root of 2 over the square root of 2. So then what we get is we get 8 square root 2 divided by square root of 2 times the square root of 2. Well, we have to do our multiplication, right? So we get the square root of 4. But the square root of 4 is just 2. So you have 8 square root 2 over 2, or alternatively, you get 4 square roots of 2. So just to be clear, this 4 square roots of 2 and 8 divided by the square root of 2 are the same number. However, 4 square roots of 2 is proper form, and 8 divided by the square root of 2 is not. Alright, and finally let's do example number 11. Alright, so example 11 is going to be 15 divided by the square root of 7. So go ahead and pause the video real quick and see if you can solve this on your own. Okay, so again, we're just going to multiply by the square root of 7 divided by the square root of 7. So what we get is 15 square root 7, and that's going to be divided by the square root of 7 times the square root of 7, or the square root of 49, but that's just going to be 7. So this is 15 square roots of 7 over 7, and this cannot be simplified any further, and so we're done. Alright, so whenever you actually end up finishing these notes, what I want you to do is write your reflection on your warm-up and reflection sheet. So write a short reflection on your warm-up and reflection sheet. Also, I know that we have a short week, but go ahead and do your homework, all of the homeworks for this week as well, and make sure that those get turned in by Friday. All right, have a wonderful day, and goodbye. I'll see you guys next week.